Morning, everybody, and welcome to this short video on how to use a software called Fathom to fit a curve to a set of data. Okay, so this is your goal here, is to learn how to determine an equation for a curve of best fit using what is called Fathom. Okay, so you have this particular activity sheet, and the problem you're up against is here. Okay, so there's some data showing the cooling temperature of a freshly brewed cup of coffee after it is poured. The brewing pot temperature is approximately 180 degrees Fahrenheit to begin. Okay, so let's take a look at that data, and here it is here. What I'm going to do is I'm going to highlight, so basically copy all of the data that's there, and then I'm going to take that into a statistical program as mentioned called Fathom. Okay, so Fathom is located on the school network. So when you go to your desktop on the tablet, check out the math folder and you should see it there. Okay, it's called Fathom 2. What we're going to do is we're going to drag down into the workspace a collection box. Now the collection box, if you right click on that, it will allow you to paste the cases. So each piece of data is called a case. So now that I've pasted, you can see that the box has been filled with the data. Okay. In fact, if I double click on it, it's going to start showing that there is some data in there. Okay, and that there are a variety of different measurements. So with that box highlighted, what we'll do is we're going to pull down a table into the space. Okay, and immediately, which is really handy, Fathom then, go full screen on this, Fathom puts the data right in. Okay. Next, what we'll do is we'll drag a graph down into the space. Okay, so the graph doesn't automatically create itself, but it's very quick and easy to do. What we'll do is we'll decide what is X and what is Y. Okay, so according to the table, temperature that's here, the temperature at which it cools, or the rate at which it cools, is going to depend on the time. So if you grab a hold of the temperature variable, okay, so click and drag, bring it over to this y-axis and release, you'll notice that it plots a series of points all at the specific y value from the table. Okay. Now the x value, same thing. Grab a hold of that, drag it over, and release, and it's going to plot each set of points. So each xy creating this particular shape here. Okay, so this relationship, that is a curve. Last but not least, to get a curve on here, to get your curve of best fit, what we need to do is to create an equation. So by right-clicking on the space, you can plot a function, okay, or plot the equation. So you can see it says temperature in Fahrenheit equals something. So if we use the exponential equation, so A times B raised to, this is the exponent key here, raised to the power of, now we said X, but in Fathom what you do, move this out of the way, is you use the name of the attribute that's there. So we can either type it in or we can find it somewhere else. For now, I'll just type it in. But it has to be case sensitive. It has to be exactly as you see it down here. Okay, so I'm going to press apply. Okay, now right now it says that it's not recognized. The reason why is that it doesn't know how to apply the A or the growth factor. So it doesn't know how to seek out the y-intercept, and it can't seek out the growth factor. So we need to define that. So we're going to bring down two sliders into the space, slider 1 and 2. So for slider 1, we're going to call that A, capital A, so it's case sensitive, so it matches this A. And this one here, this will be the growth factor. Okay, so again, whoops, call that B. And you'll notice that it is now trying to plot a relationship or an equation of this style, AB to the x, but with an A value of 5 and a B value of 5. So those are default values. Well, if A is the y-intercept, you can see how it seems to be crossing nearly at 180, because that first value was 179.5. So I'm going to actually set that manually. You can slide this along, and you can adjust the scale if you like. Do that. I'll slide this up just so you can see that it's going to, you can see how it's approaching the y-axis quite a bit. So I'm just going to set that at 180 for now. I'll do that manually. But we need to make this thing curve out. Okay, so to curve out, we need a decay factor. So the decay factors are between 0 and 1. So if I set that thing at, you can see it just start to curve the other way here. If I put that at about 0.9, you can see how it's starting to bend upwards. Then it goes too far back. So let's leave it at 0.94. And then what we'll do is we'll start adjusting this value here. So let's try 0.98. Much closer. Okay, let's try 0.99. Too much. So we can either lower the y-intercept or we can try to reduce that. So reducing it, let's go an extra decimal place. Let's go 0.985, the nearest thousandth. You can see that really does help shift the curve quite a bit. Let's go 987, see what that does. Brings it up even more, 986. Not bad. Okay, it's not bad there. We could raise the curve a little bit. I think I was a little more happy with the 987, so let's leave it at that. Okay, and possibly drop this a couple of values. And that's a fairly good fit. Okay, so the equation, if you have to save any piece of work and use that either as a printout or as a demonstration, the text box will write that. You could say that y equals, for this line or curve of best fit, 178 multiplied by a decay factor of 0.987. I have an extra 9 in here. And that's raised to the power of x. Or you can use the attribute names. So temperature equals 178 times 0.7 to the power of the time in minutes. So the time is the variable. Okay, that's a quick tutorial on how to use Fathom to graph a curve of best fit.